Hey guys, just sitting here eating my lunch. I've got oatmeal. What do you have for lunch? Okay, today we're going to be talking about triangle inequality theorems and Pythagorean inequality theorems. So, here's what you need to write down. The sum of the lengths of any two sides of a triangle must be greater than the third side. What does that all mean? Well, first, pause the video and write that down. Okay, example 1, 8, 15, and 17. What it's saying is, when you make a triangle and you make the sides, when I give you examples and I make sides in a triangle, you always have to check and make sure the sides can actually work. So the way you do that is you add each of the sides. I'm going to take 8 and 15. If I add 8 and 15, I get 23. As long as that adding together is greater than the other side, 23 is greater than 17, so that works. Now I have to add 15 and 17. If 15 and 17, that equals 12, 32. As long as 32 is greater than 8, that works. And then add the other two sides, 8 plus 17. Add those together, you get 25. That is greater than 15. So this can be a triangle. This is a possible triangle. Example 2, if you notice, I have 6, 8, and 14. If I wanted to see if that was a true triangle, if I could really do this triangle, if I add 6 and 8, I get 14. But 14 is not greater than 14. You cannot have a triangle with these lengths. This would not work. For example, if I had length 1 on one side and 1 on the other side, and then a really long length, or, that just wouldn't work. So we're just trying to see if these triangles work. Specifically, we're going to use the Pythagorean theorem. So we're going to learn the Pythagorean inequality theorem. So you need to take this in your notes. Today's lesson is actually, or tomorrow's lesson when you're doing it in class, it's actually going to be, it's going to be pretty easy. It's a matter of squaring things and seeing if the triangle is acute, if it's right, or if it's obtuse, or if it even works at all, because when you have a triangle like I just showed you, that the two side lengths aren't long enough, then you're going to say that that triangle doesn't work at all. So let's see what I mean. Theorem 8.6. This says, write this down. If the square of the longest side of a triangle is less than the sum of the squares of the lengths of the other two sides, then the triangle's acute. So we can tell if the triangle's acute by the lengths of the sides. What you're going to do is you're going to figure out a squared, b squared, and c squared. When you do all that, if c squared is actually less than those two combined, a squared plus b squared, you know it's acute. So this is an acute triangle. And I'm going to write it again. When c squared is less than a squared plus b squared, it's acute. Over here, the other example, if the squares of the lengths of the longest side of a triangle is greater than the sums of the squares of the lengths of the other two sides, then the triangle is obtuse. So what I'm saying is, for this triangle to be obtuse, when you square c squared, a squared, and b squared, if you square a squared and b squared, add them together, c squared is going to be bigger than them, and that's going to be an obtuse triangle. What happens if we know a squared plus b squared equals c squared? If a squared plus b squared equals c squared, hopefully you know that that would be a right triangle. So a right triangle always has a 90-degree angle. Let's take our examples, okay? First thing I always have to check, is this able to be a triangle? If I add those together, it's bigger than that. If I add those together, it's bigger than that. If I add those together, it's bigger than that. So I've already done the triangle inequality theorem. So I'm going to take the biggest side, it's 16. And I got my calculator. Because I have to square all this stuff, I'm always going to make sure, I'm going to put a little equal sign here because I'm not sure what's going to happen. 16, I'm always going to make sure that's on that side, the c squared side. So what I have to do is square these two and then see what happens. I know 7 squared is 49, and 14 squared is 196, and 16 squared is 256. So when I add 49 plus 196, I get 245. 245 is less than 256. Since a squared plus b squared is less than c squared, a squared plus b squared is less than c squared. That means c squared is greater than, I am in the obtuse type of triangle. If c squared is bigger, so this one is bigger, this is my c, that's bigger. This is an obtuse triangle. Okay, that's all we're trying to figure out, what kind of triangle it is. Let's look at this one. 9 squared is 81. Well, I have to make sure, first always check your triangle inequality theorem first. Add those two, bigger than that. Add those two, bigger than that. Add these two, bigger than that. So far it can be a triangle. 9 squared is 81. 40 squared is 40 times 40 is 1600. And what happens to 40 with 41 squared? 41 times 41 is 1681. 16 plus 81, 1681 actually equals 1681. Okay, what kind of triangle is this one? It's right because they equal. Okay, my last example, I'm going to erase this, is 11, 60, and 61. Those added together are bigger than that. Those added together are bigger than that. And those added together are bigger than that. 11 squared is 121. 60 squared is 3600. 61 squared is 3721. 3600 plus 121 is 3721. 3721 equals 3721. When they equal, it's going to be right. Okay? Now if we did one more example and we got, let's say I added a squared plus b squared. We'll do, I don't know, let's say I added a squared plus b squared and I got 50, and then I got c squared to be less, so we'll just say it was 48. In this case, if this was c squared, then this is greater than that, and that would be acute. So what you're going to be doing today is figuring out by squaring a squared plus b squared and c squared, seeing if c squared is bigger than the two added together, seeing if it's less. So then we're going to go with acute, obtuse, right, or not a triangle at all. Okay, we'll see you tomorrow. Bye.